Hello interwebs, welcome to Let's Fix Computers. I've got another Dell in today. This one is an Inspiron. It's an Inspiron 5100 maybe, question mark, because Dell don't put the model number on the bottom of them. It's a Dell Inspiron, and it's got exactly the same problem as the last video that we did, which is the charger light goes out when you plug it in. So I'll demonstrate that again for good measure. So, oh, the charger is already off. Let me just replug it. So we've got a light on the charger here. This one's built into the charger tip. And if I plug it into the laptop, it goes out. And the laptop does not turn on. So in order to reset things, I need to unplug the charger. And I'll just plug the charger in again. And the light has come back on again. So if you watched the last video, you should have a pretty good idea on what to expect with this one. So this will be a good test of your knowledge. So what I'm going to do is I'm going to take the back screws off. We'll take a look underneath and see what we can find. And while I do this, you can have a think about what you learned in the last video. Now, this being a modern Dell, as you can see, it is drastically easier to disassemble. So, with the charger light going out, we're expecting to find a power fault in here. We're expecting to find a short circuit somewhere, probably on the main power rail. So, what we're going to do is disconnect the battery. And we're going to have a look up here. This is the DC in jack here. It goes on a tiny little 1-inch long cable to the motherboard here. So let's take a closer look at this area and see where the power comes in and see where we're going to take our initial measurements from. So here's a closer up view of that section. And if I just peel back the black cover here, hopefully we can get a look at the wires. There we go. Splash of red there and a splash of black. So we've got two reds on the right, we've got two blacks on the left, and there's a sense pin in the middle. So I'm going to put my black probe on the left-hand side. And I'm going to put my red probe on the right-hand side, and we're going to check across the DC jack. And we've got 13 kilo ohms. That's pretty low for a Dell. That's not a short circuit. This is probably indicative of a problem deeper in the laptop. So yeah, HP laptops are often quite low, like 13 to 20. However, other Dell laptops, I expect to see like 50,000 ohms or more. So yeah, that's pretty low, but not a short circuit. So let's go deeper. So once we come out of the positive terminals, we're coming up to here. We've got what looks like a TVS diode there. I'm going to verify that. If I put my black probe on a ground point and I check that side of the TVS diode, we should find that's ground, which it is. So what that is a TVS diode, which is a transient voltage suppression diode. And that is wired there to protect it against transient voltages, which will be like static shocks, lightning strikes, just gross over voltage, that kind of thing. So if we see a high voltage coming into the laptop, this guy will very rapidly conduct and it will just clamp that down to ground to protect the laptop. So that is our protection diode. So from this angle, I can't see where the power goes from here. So let's go under the microscope and see if we can see anything else. Otherwise, we might have to get the board out to be able to see anything else at all here. So let's look closely. And the answer to that is no, we can't see anything else. So we've got our positive pad here, but there's nothing to see. So there's almost certainly going to be a bunch of vias either under this diode, or is it going backwards, I wonder? It could be, actually. Let's just unplug a few things and take a look. If I disconnect the display here, So yeah, the vias are under the connector, under the diode, they're out of sight. So to progress this any further, we need to take the motherboard out. So let's carry on stripping this thing down. So now we're on the other side of the board. This is the other side of the DC input pad, so you can now see where it goes through the board. Then we immediately go through two 0-ohm resistors. So these are essentially just acting as fuses by the looks of things. And then after that, we're going down into this MOSFET. And then from here, we're going into this guy. And then we've got an output to there. And then there's a third one. So this might be to do with battery charging as well. Now, there is, it was pointed out to me after the last Dell video we did, I need to brush up on how the power rail and battery charger systems work on these laptops. Because I got caught out by that last one where the main power rail wasn't shorted, but it was just before around the charger area and stuff like that. There seems to be an area where I thought I knew that power section better than I did. And I can see another misunderstanding coming here. But we don't need to be an expert in how this works. We just need to find the short. So let's start probing and see what we can see. So I'll stick my black probe on ground. So our input is not shorted. We already know that. We'll just confirm that. Yeah, so there's that same 13-ish kiloohms that we saw at the DC jack. No surprises there. So let's go down to this spot in between the DC MOSFETs. Yeah, same deal, 13 kiloohms. So now let's go over to the output. And there's our short circuit. About 0.4 ohms. Good, that's nice and low. That's what we like to see. So these are two main DC input MOSFETs and the output is shorted. This one, I'm not sure where this is going. I'm not super fussed right now. We've got some vias going through the board. So let's see where those come up on the other side. Okay, those guys come up in this maze of what look like transistors. I have no idea what's going on here without looking at a schematic, if I'm honest. We might need to get one out and have a look to better understand this. But once again, let's see if we can push on without needing to do that, because we do have a simple problem. So what we will do though, let's start looking elsewhere. If we go over here, here we've got the CPU vCore. So once again, I'm going to check if the input to vCore is shorted out. Now I'm expecting the answer to be no here, for the same reason that it wasn't on the last Dell we looked at, is I think these guys are all going to be behind another rail. So where do I think the input? So these are power stages or DR MOSFET packages. So one side of these is going to be ground, the other is not. Let's check. All right, we've got ground there. And this side, which is probably the input. Yeah, that's got lots of kiloohms on it. So yeah, vCore is not shorted. So this is, again, just exactly the same as the last Dell we looked at. And the good news is this means that we can kind of go in guns blazing here, if I'm honest. Because we don't have, because our short circuit doesn't go up to the CPU or anything, I don't need to be too worried. So for that reason, again, I'm going to go straight to voltage injection, quite frankly. So let's do it again. So I've just done a little bit more probing around because these MOSFETs are kind of small. I don't really want to try and inject directly on there. And again, this maze up here, I've no idea what's going on up here, if I'm brutally honest. So we've then got to ask ourselves the question, okay, well, fine. again, we don't know where we're going from here, but we do know that there are some things that have to be true. The power comes in there. At some point, it needs to reach the battery charger, and at some point, it needs to be transformed from DC in to the main power rail. So we can see that doesn't look like it's happening around here, because this, although we've got our shorted rail here, it doesn't go anywhere. So let's look at what else we've got available. So the other place where we're going to find large power stuff is over at the battery connector here. And if we start looking around this area, things start making a bit more sense. We've got a big inductor here, and big inductors mean big power rails. And on the other side of the board for there, we've got more MOSFETs and action going on. So it's incredibly likely that the DC in has to come up here somewhere in order to hit the battery charger. And if we do some probing, that's exactly what we get. So we've got some current sensing resistors here, but if we move further back, I've just gone all the way back through all of these MOSFETs to the input sides here, and I've found that the input to this guy is shorted out, because that is reading 0. And by extension, we've got a nice big pad here, and we've got some capacitors here. These capacitors are also reading ground on both sides. So again, we know that has to be a short circuit, because on a power rail like this, capacitors should be joining the power rail to ground. So you should not be seeing ground on both sides. Likewise, if I turn the board over, we've got another current sense resistor here, and this guy is also reading as 0 ohms. So this is where the DC in gets turned into the main power rail. So that starts making more sense, and we've got a bit more to go on now. Now, I could look up the schematic and we can have a look at what goes on from there, but I'm actually going to save that for another video where I want to start going over how the battery charger circuit works and stuff like that, because this is something that I need to refresh my own knowledge on, because it seems like I didn't, as I say, it seems like I didn't know that quite as well as I thought I did. So I'm going to research it and I'll take you along for the ride. I have some guides that I shall be following. So anyway, the point is we've got a nice easy point of injection there. So I'm going to hook up some jumper wires. Let's see what gets hot. And once again, as a friendly reminder, because this short is on the DC in side, not on the main power rail, we don't need to worry about the CPU because these inputs are not shorted. Therefore, we cannot have a failed power stage up here. So we can just go ahead and just stick voltage into this and see what heats up. Normally I prefer to solder on jumper wires, however everyone else seems to use a crocodile clip and a probe these days, so I'm going to try my hand at that. So I've got my crocodile clip just clipped onto a ground point over here, and I've got my 1 volt at 2 amps on the probe. So let's get the camera pointed down at the board, and I'm just going to touch that on the shorted pad and we'll see if anything lights up. We've banged up to 2 amps. So there's some reflections on the board. And is that some heat forming down here? Might be. That is a screw hole. That's another screw hole reflection there. We've got some heat on the crocodile clip. Not sure if that's a bad connection. That might be reflection as well. I have to keep my hand in view because this thermal camera doesn't have a calibration lock. So I can't just, as soon as I take my hand out of sight, it tries to normalize again, which is why I'm constantly trying to put my hand in shot. Okay, I'm not seeing anything here. Let's turn the board over and see if there's anything on the other side. So I have to come off of the power to do this, and I've got to find a new point to inject at now. This is kind of why I don't like doing it this way. Interesting test though. that our guy right there? I think it is. That's a pretty big flare up. Alright, so who's that? Is that the capacitor? See, I've got to put my phone down now because I need an extra hand. I think it's this little guy down here. Yeah, I definitely prefer soldering wires on because, well, I mean, to be honest, if I've guessed correctly, then it worked. But this is exactly what I'm glad I tested this because this is exactly why I prefer jumper wires, because I'm having to put things down in order to look closer at things. So yeah, 6 of one and half a dozen of the other, really. Oh wow, yeah, oh that guy's turbo dead. Yeah, that cap is mega dead. You can clearly see the fractures through it. Good. Alright. Power off. Right, let's go. So we're going to take that capacitor off the board, and then there's a couple of dudes just below it, and I'm going to take those off as well and measure them, because there's a good chance they're the same value, and that'll tell us what we need to replace this one with. I'm going to bring my airflow down a little bit for this one. I'm going to try and be gentle, just to save me having to mask off the entire area. So I'm going to go in a little bit close. It's going to make it harder for you guys to see, but I want to avoid the plastic nearby. Go on, I need to get on top of that a bit better. Blocking the view of everything. There you go. We going? No, not yet. There's one. And moving on up. Let's have you as well. And just out, just for good measure. Also going to grab this guy. So first of all, we should now find that our short circuit is gone. So we can go over to here. This current sense resistor was previously shorted to ground and is no longer shorted to ground. We've got lots of kilo ohms and rising. And for good measure, we'll just jump back up to the DC jack where we found our short circuit earlier on. So here's those DC in MOSFETs. We should find that these guys are also no longer shorted to ground. So if I just jump in the gap between, let me see, it was the output there. And that guy's also showing kilo ohms, hundreds of kilo ohms. Good. So primary objective is achieved. Let's have a quick look at our capacitors that we took off the board. So this was our dead one. So this guy was the fractured one. So we're going to find that this guy is in a dead short circuit. Zero ohms. Perfect. Okay, that's over there now. And now the two that we also took off, we're just going to check the health of these. We don't believe that these guys are faulty, but we're going to double check them and also just measure their values. I'm going to take a shot in the dark that these are going to be more 22 microfarad capacitors, because that seems to be the thing for these areas. Either that or they're going to be 10. Right, and check. Oh. And it's gone. Well, never. That one landed on the floor somewhere. You know, I'm going to go back to using my little component tester because it was a lot safer to pinch SMD components between that. Or maybe I should stop pressing so hard. Okay, there we go. That guy is over limit. Good. Okay, right. What's the value on it? Let's go up to capacitance mode. It's a 10. All right, that's good. 10 microfarad capacitors. Cool. I'm going to stick 3 10 microfarad capacitors on here then. I'll put this guy back on the board. He's probably fine. Flux. And we'll just put some fresh solder down on those pads. And I'm going to turn that around again. So by putting it at this angle, I give myself a bit of I give myself some walls that I have to work around. However, the purpose of this is that I can blow the hot air away from the plastics, which makes my life a lot easier. And we're going to go low air, 4 out of 10. And let's come in and flow. Ah, balls. Oh god, those have all stuck together already. Detach. There we go. Oh, you've just tombstoned. There we go. Right, get you jiggling. Get you jiggling. And get you jiggling. Perfect. Now I'll squirt some alcohol in there just to get rid of the flux. And I'll just toothbrush that out. There we go. That top one's not perfectly straight. However, it's on. That's good enough. Sometimes less is more. All right. So now we've just got to reassemble this thing, and we should find that everything is A-OK. I will just quickly buzz that rail again after putting on the new capacitors and make sure that nothing terrible happened. Black probe on ground. And yeah, we've got mega ohms of resistance there. So that just confirms that I didn't accidentally put the broken capacitor back on the board. Anything is possible. Right, board in the laptop. Reassemble time. While I put these screws in, I'm just going to quickly have a chat about it being another short circuit. Because I saw a YouTube comment the other day or over the weekend that was words to the effect of, oh, it's another short circuit. Looking forward to the day when a YouTuber fixes a signal line, you know, a logic problem. I agree. I am conscious of the fact of it's another dead capacitor kind of thing. And you know, I have done signal or trace repair, not trace repair. I have done signal repair before in 1 or 2 videos. I had a recent MacBook Air where we had to work on some signal stuff, which was interesting. But yeah, I don't do it on purpose. If anything, take this as a demonstration that while absolutely bad logic signals are a thing that exist, and there does need to be more content about tracking them down. But for my level of repair, what I want to demonstrate in these videos is that these kinds of problems are incredibly common in laptops. And if you want to get started in board repair, which is who these videos are aimed at, people who are getting started with board repair, then this is the kind of fault that you want to start looking for and learning how to approach. Because it's fairly approachable, as you can see. And if you can handle this, then you will be very well primed to deal with the more serious stuff. So I don't deliberately avoid the tough ones. This is just what I see most of the time. It's also worth bearing in mind that, I am not the be-all and end-all of board repair by a long shot. And this is not me being sort of self-deprecating, as some people have misinterpreted it as. This is me just knowing my own limits. So, as I say, these kinds of repairs are very common, and I'm kind of hoping with these videos that it shows that the lower level board repair stuff like this can be incredibly accessible. You've just got to be brave enough to start looking, basically, and sometimes have a little bit of luck as well. Okay, I'm going straight on with the back cover here because I'm going to be super confident. Do as I say, not as I do. Test it before you put all the screws back in. Right, charger, light is on. Plug it in. The light is still on. We have a charge light on the side of the laptop. There we go. Oh, you can see that into the thing anyway. Yeah, it's here and there. The battery's probably dead. We have a sign of life light. The laptop is turned on automatically. On modern Dell laptops, the caps lock light coming on solid like that, this is called this sign of life. Because the laptop doesn't have a power LED, it uses the caps lock indicator to show that the laptop has switched on before the screen comes on. And that's called sign of life. I tell you what would be a lot easier than that is having a power LED. But hey, I don't design these things. Thankfully, it works. Great success. So, we found, exactly the same as the last Dell we looked at. But again, repetition is the key to learning. And also, this again demonstrates that even though short circuits like this are easy source and easy fodder for YouTubers like me, they're common though, man. So, if that's what comes along, that's what comes along. I didn't line up 2 of these in a row on purpose. It's just what comes along. Anywho, thank you everyone for tuning in. As always, links to my social stuff is down in the description below. We've got the podcast on Saturdays with Caradog, where we talk about tech, sometimes fix stuff, and look at things we think are interesting. And I stream on Twitch Thursday and Sunday evenings, 7 p.m. UK time. Links are down below as well. And a big thank you to all the Patreons, subscribers, Twitch subscribers, YouTube members, and everyone else who makes these videos possible. Thank you, and see you next time. Bye.